Welcome, everybody. We'll get started here in just a few moments. All right, let's get started. Thank you, everyone, for joining us today. We have a great webinar prepared for you on a very important topic that is facing the imaging informatics community. Lots of people are working on helping to solve some of these challenges. So wanted to give you perspectives from it's an amazing group of folks. So hello to our friends from around the world. My name is Nikki Medina, Director of Education here at SIIM, and I will serve as today's moderator. Welcome to Series Nomenclature Standardization, brought to you by the HIMSS-SIIM Enterprise Imaging Community. This webinar is eligible for 1 hour of IIP credits towards your ABBY certification. Our CP HIMSS folks can also use this for their other credits, towards those 20 hours of other credits that they need. Throughout the webinar, we're going to ask that you ask your questions. We will answer them all at the end, but as we're going through, there's going to be a lot of topics and content that's covered. So feel free to drop those questions in the Q&A box in your menu. If you throw them in the chat too, we'll pull them out, but we do try to facilitate them all in the Q&A module. So as you can see, we have a great lineup for you today. Today, we would like to welcome Dr. Ross Felice. Ross Felice is the Chief of Imaging Informatics at MedStar Georgetown University Hospital in Washington, D.C., and also serves on the RSNA Radiology Informatics Council as the chair of the RSNA RadLex committee. Also joining us is Dr. Kent Hudson, who is the neuroradiologist and director of AI clinical operations for Radiology Partners. He is responsible for evaluating AI solutions and integrating them into the clinical workflow. He is a strong advocate for the sensible application of informatics in the practice of radiology and uses his formal training in computer science and medical informatics to bridge the gap between informatics and imaging. Dr. Hudson is also a certified physician executive, combining years of experience as a radiology department chair with practical knowledge of radiology management and quality improvement methods to integrate AI into clinical radiology. Dr. Gloria Huang serves as Associate Chair of Clinical Performance Improvement at Stanford, where she leads the IT Operations Committee and the Performance Improvement Committee, and also co-represents as a Medical Informatics Director for Stanford Healthcare. In her role, she partners with organizational leaders in overseeing the portfolio of imaging applications and analytics, as well as collaborates on meetings the imaging needs within and outside her department. Dr. Audrey Verde is one of the health IT leaders at Vanderbilt Radiology with a focus on PACS and workflow optimization. Prior to Vanderbilt, Dr. Verde served in a leadership role on the Stanford Radiology Informatics and Operations Committee during residency and fellowship, helping to select, configure, and optimize PACS and trainee workflows. Dr. Verde also participates in the ACR initiative to ditch the disc and working towards seamless electronic medical image exchange. Also joining us today is Dr. Mark Coley, who co-leads Imaging IT at UCSF, focusing on operations and clinical support for a variety of clinical services at UCSF. Dr. Coley has an extensive record of service to informatics such as former chair of the board of directors for SIIM. Mark also participates on the Radiology Informatics Council, the RIC, for RSNA, as well as co-leading the joint RSNA ACR Common Data Elements Committee. And last but not least, Dr. Ken Wang is the MRI section chief at Baltimore VA Medical Center and an adjunct professor at the University of Maryland School of Medicine. He received his PhD in electrical engineering from Stanford University and his MD from the University of California, San Francisco. He completed his residency in diagnostic radiology and fellowship in musculoskeletal imaging at Johns Hopkins, as well as a fellowship in imaging informatics from the University of Maryland. He co-chairs the RSNA ACR 3D printing registry and is currently the assistant editor of informatics for the Journal of Radiology Graphics. Welcome to this esteemed panel of folks today. 1 second, and I will pass along controls over to Dr. Coley.
Thank you, Nikki. And thank you everybody who's attending the webinar. Great to see some familiar names in the participant list today. So when UCSF went through our PACS transition, we decided that we had an opportunity to address the wild, wild west of series descriptions. And you know, these series descriptions are created sometimes intentionally and sometimes unintentionally by different groups of folks, including, you know, our technologists, sometimes our biomedical colleagues, and sometimes the original software engineers who are developing the scanners actually are crafting these series descriptions. And there really isn't any consistency because of that. Even on the same scanner, you know, different the same exact modality model, different implementations, different software versions. There's just massive heterogeneity. There's no consistency. And one of the things that we learned is that some vendors even hard code pieces into their series descriptions and say grab characters that you can't change. So there's just a lot of opportunity here, I think, to improve the series descriptions. Hopefully on this next slide, I could convince you about a little bit of why it might be valuable to try to manage these series descriptions. That is that they can be used to drive clinical workflows. You know, increasingly as we think about artificial intelligence applications, a lot of times an AI application may not need an entire study or may only need a particular series from a range of studies. So being able to do things like use an AI orchestrator or my DICOM router to selectively send image data to an AI model is important to be able to do. And increasingly as the AI models run in the cloud and there's things like network costs associated with that, storage costs associated with that, people don't want me to send them all of my chest CTs, which is what I do with one of my AI vendors right now. So there's a lot of opportunity to change to sending things much more granularly, but we need to be able to know the content of the images in order to be able to do that. And then if any of you are working in academic institutions, you understand that there is an opportunity. We use those data again for research. So if I have a study where I'm trying to train a new model and I want to only see the T2 flares from the brain, trying to find those in this massive data set for research can be a big challenge. So those are some of the reasons why we could convince a number of other folks here at UCSF that this was worth tackling. So our idea was that we would create a set of rules for the series descriptions such that any two people who both knew the rules would actually come up with the same rule or the same name for a particular study description or series description. And so we quickly realized that we needed to define a few things. We needed to create a set of principles about how the series descriptions would be put together. And we also had to create a set of words or a shared lexicon for both body parts and then things like CT slice thickness and MRI pulse sequences that could be reused over and over again. We decided that we were primarily focusing on CT and MRI at first. Ultrasound, we identified that the majority of the way that people read that is based on the order that images were acquired, and the study descriptions aren't as important for that. So we did not tackle ultrasound initially. You can see just a short example here of a bit of our lexicon for body parts. And then we also, sorry, clicked in the wrong place there, had created some vendor independent names for MRI sequences. There's a lot of detail that goes into this, and many of my colleagues will start talking about that in more detail. We did implement this when we went live with our new PACS about a year ago. This is a screenshot from a pivot table summary of some audit data that we have. And you can see that this is just for 2 months worth of CT abdomen and pelvis with contrast. And you can see that a lot of the series descriptions that are baked into the scanners, like dose reports and dose records, have really high frequencies. You can see that we still have some opportunities with some non-standard names, but some of our standard names are starting to creep up in here and be used and deployed pretty consistently, especially on some of our new scanners. This 3 is one that was a scanner that was new. So we're just starting to try to audit this and create some feedback loops here at UCSF, but we've had some mixed success with deploying this so far. John Mongan and I developed this together along with some participation from other folks here in other clinical areas. And we recognize that this could have a potential value to the larger community. And so we brought this to Ross and the RadLex committee and said, you know, is this something that the RSNA and RadLex would be interested in taking on? And so I'll let Ross take it from there.
Yeah, thanks very much, Mark and Nikki, and all the panelists and the folks attending. So, yeah, one of my roles now is the chair of the RadLex committee, which actually Dr. Wang used to be the chair. So we have 2 of the 4 chairs here today, which is great. And the rest of the folks on this webinar are going to cover a lot of the meat of what we've done so far around series name standardization. So I thought I'd take a little bit of a step back just to briefly cover, you know, RadLex and kind of where we've come from. I think many people on this call are probably familiar, but you know, RadLex has been around now for about 20 years. It's an RSNA initiative to try and standardize radiology terminology to fill in some of the deficiencies that we saw in other standard terminologies like SNOMED. And it started out just as an ontology of entities, but since about, I think it was 2008, the one of the initiatives that the RadLex committee worked on was, oh, sorry, Nikki, I'm not sure I can advance, or either I'm doing something wrong or I don't have permission, maybe.
Try now.
Okay. There we go. Okay, great. And this is the RadLex term browser that you can visit on the web to look at the terms and the, you know, what exists there in the hierarchy, the relationships, etc. But one of the initiatives that directly relates to this work is that since 2008, there's been an initiative to standardize exam names. So at the exam level, not the series level, and that is the RadLex Playbook, which is now a joint effort between RSNA and LOINC, which Dr. Wang will discuss a little bit at the end of the lecture portion of this. And this is basically the analogy of exactly what Mark described for exam names. And it allows you to share exams across institutions or analyze exams across institutions and understand what actually lives under those exams without having to try and figure out the different ways that people may have named them. So when I became chair, you know, talking to a lot of people out there are having the same problems that Mark and John and other folks at UCSF did in terms of standardizing their series names for all of the reasons that Mark already discussed, but for things like hanging protocols, you know, things that actually happen at the workstation for your radiologists, a lot of behind the scenes things. If you want to route exams or route just particular series, maybe you're routing just your 3mm soft tissue series to have inference run out of by an AI model, and you don't want to route the whole study. And certainly research initiatives too for AI development or other research where you just want particular series out of a very large study. And we've discussed things with MIDRC actually, which is a pooled repository of initially COVID data, where you could use it to better structure pooled repositories and other common repositories of data so that you can easily find certain exams and now hopefully go to the series level. So we really had a lot of enthusiastic responses from people across the country at academic sites, private practices, et cetera, who thought this would be a great idea. So we decided to make this one of the next RadLex initiatives. And we were so lucky to get in touch with Mark and John, who had already done a lot of work on this. I mean, we will probably modify things to some degree, but the foundation of the work we've done so far to date, which you'll see in a minute here, is based largely on the great work that UCSF did already. So before I move on to the next speaker, I just want to thank this group here also has done an incredible amount of work in putting together the work you'll see coming up next. I mean, I'm glad to have served in my role as chair, but the real meat of the work that we've done so far and really making this initiative move forward has been done by the folks you see here on the webinar today. So I'd just like to thank them on behalf of RSN and RadLex.
Thanks, Ross. So I'm going to talk about the Sandbox, and it's really just a spreadsheet that we use to collaboratively iterate on some of these ideas about series standardization. It's cloud-based. Different practices can enter their protocols and see what the series names would look like. And I'll walk you through the drop-down menus and kind of how it auto creates the names, the proposed names. So we start out with the CT field definitions. This is just for CT so far, right? So in each column, you'll see a relevant parameter for the protocol, and then a list of the standardized names that we've decided on. All of this still a work in progress, obviously. The next step is the drop-down menus. So if you want to enter in a CT protocol, you would go to this page, and for each row, it represents a series, and you just click on the body part, on the anatomic plane, whatever the parameter is for that particular protocol, and then magically forgot about the CT exam. So we did this for a number of CT exams for 4 different practices, and to try to get a feel for the variation among those practices. And when you enter in those fields, those drop-down menus, you get a selection of different possibilities for series names. And because we were trying to iterate and figure out, okay, what looks the best, what works the best for the hanging protocol use cases, the AI use cases, those. What's the best way to display that series name? So we've experimented with these, and you can see some of the series names there. To zoom in a little bit on the lowly CT head without contrast, you can see some of the series names that were generated for one of possible CT heads, CT head protocols. So, and with that, going from the lowly simple head CT, I'll pass the baton over to Dr. Wong to discuss the complexity of generating these things.
Thanks so much, Kent. So I thought that the task that we were presented with was going to be pretty easy. We were told, like, let's start with a head CT. Like, just tell us what your organization does in terms of different series types, and see if you can map it to these standards that that UCSF had pioneered. And so I decided to kind of use the qualitative research approach and just kind of go down through a list of head CTs until I hit a saturation of different head CT types. What I didn't expect at Stanford was that we would have at least 6 different ways. I think there are actually more than what I'm showing here, of how we acquire a simple thing called a non-contrast head CT. And that's not even like, we have over 2,000 procedure codes. We actually have head CTs that are done with indication-specific procedure codes. This is specifically just CT head without IV contrast. And we had this many different series types. We also found for something else I thought should be fairly straightforward, which is CT abdomen pelvis, that we had very, very many different ways that we would acquire something that looked as basic as a CT abdomen pelvis with IV contrast. I don't think we're unique in this, but I think we maybe are at one extreme of how many different ways we acquire the same thing for even just one procedure code. And one thing that we found at Stanford was, in addition to what you might consider basic series, such as axials of different thicknesses, basic reformats such as coronal sagittal planes, perhaps 3D reformats, that we also had strange complexities that were mapped into our series names, such as sometimes rather than acquire in a or generate images in a 512 by 512 matrix for CT, we would actually have 1024 by 1024. And those are very dense studies, and we wanted to label those separately. We also could have very similar reconstructions coming from 3 different sources, including directly from the scanner, from the 3DQ lab, or saved from reconstructions within packs performed by the radiologist. One of the biggest introducers of complexity was the fact that some of our scans are performed on dual energies or spectral CT, and those would include metal artifact reduction if requested, virtual and enhanced images, and iodine maps. But a lot of our scanners are not dual energy and would not offer those only because they're not dual energy. And we are looking into photon CT in the near future, and that again will add additional complexity. So some of the complexity is self-inflicted. Just as Mark said, different scanner brands, different scanner ages, different scanner sites. Organically, things just kind of got named what they got named. And then we also found that with dual energy, there are different scanner capabilities, and that introduced some variability. And then the way we protocol, there were different indications, which would lead to different series being generated. And those are all technically controllable within our institution. What we can't control is that we also ingest several outside organizations' exams. And so whatever their series names are in DICOM field 0008103E shows up in our series description in our system. And so making series name standards, creating series name standards are great. There are so many things that they will fix. When you have the kind of complexity that we see at Stanford, our display protocols don't work much of the time. And it's really hard on referring providers. They complain at every tumor board how hard it is to get through our exams. But the one thing that they do offer for people who have created these is that our radiologists know what each series does and has a reason for the name of each series. And so when our radiologists are reviewing their images, they can efficiently go through a lot of complex data. It communicates all that information in one panel, and it's hard to find the information elsewhere. You have to hunt and peck. And so as we do go into standardization, one thing that we probably will need to look into is how do we make it just as easy for the radiologist to find the specific information while we're gaining the benefits of standardization. And here are just some examples of the craziness of our current state. For example, display protocols. I can guarantee you that this exam on the right does in fact have a sagittal series, and I cannot explain why it didn't automatically pull up. There is even a named sagittal series. And here's just one example of MRI. This is one exam. All those series are just from one exam, and this is what drives our referring providers crazy. And I think having some standardization so they just know like standard, what are some of the common series that people use would be very helpful for them. Thank you very much.
Thanks, Gloria. So I'm going to talk a little bit about, so when we meet to discuss our central sandbox and what fields to include, so we did start based on UCSF's initial work, but we have further discussed since then to try and figure out which fields, which elements to include in a series name and what level of detail. And part of our guiding principles was that we wanted the standard series to be vendor neutral. And like Mark said, where some of that is vendor information is ingrained in the series name, it's also ingrained in a way in the slice thickness. And so this is something that we talk about often is, so if we want to make this vendor neutral and to have it applicable to both academic and private practice centers, we have to think about how we're going to label the slice thickness. And so currently at most places, there's actually the number, but some vendors or most vendors, they use different numbers for their different levels of slice thickness. And so even if we were to keep the number, you'd be able to tell the vendor. And so to try and remove further from that, we've discussed using categorical groupings of slice thickness, such as what I have listed here as recon, thin, regular, or thick. Other things that we've called this when chatting about it is either thinnest, thin, medium, thick. And where to put these cutoffs is a hot topic of discussion because there are different use cases between academic and private practice and what this will do to the resulting series names. And so this is something we're still thinking about and still under discussion, but it's something that we would love input and feedback on, because this is going to be important going forward to ensure that this solution is vendor neutral. And then the other thing we talk about often is just the underlying philosophy of this work. And do we go at this with the philosophy of creating an exhaustive list of options of series name elements and series name element definitions, so that we can fit any type of exam, be it academic or private, which is going to be a giant task? Or do we focus on a more feasible task of series of the core elements, so that the vast majority of the most completed exams, the most commonly completed exams at academic and private practice settings are covered by these guidelines? And so these are things that we would love to have a conversation around and feedback on, because this will help us better inform us on how to continue developing this process. Now I'll hand this over to Ken.
Great, thanks, Audrey, and thanks everybody. I think that it's really useful and interesting to see the definition of this problem and to see the illustrations of some of the complexity involved. I think that's really useful for us as a group as we try and kind of devise solutions to it. I'm gonna, in the vein of what Ross did, I'm gonna also kind of take a half a step back, and I want to provide some perhaps relevant context to this discussion and say a little bit about LOINC. As Ross mentioned, there has been a history of a collaboration between the RadLex project and the LOINC system around radiology exam descriptors. That is the Playbook project. So I want to tell you about Playbook a little bit, but first, what is LOINC? LOINC is it's a standard for clinical observations. Clinical observation could mean anything from a serum creatinine measurement to an EKG to a chest X-ray and any number of other things. LOINC's a system that's been around for coming up on 30 years now. It's freely available and it's used all around the world. All right, so anyone can go to loinc.org and get a free account to download content, to get documentation, and to browse the material that make up the LOINC system. One of the ways that you can do that browsing is through this search interface, search.loinc.org. And if you just go to that interface and you apply the filter class:/rad, that gives you all of the radiology LOINC codes. And again, these are the Playbook codes, which refer to orderable imaging exams. And the first two that come up are a cardiac CT and an X-ray exam of the cervical spine. And each one of those has its own LOINC code, which is that digit with a hyphen and a final digit shown on the left-hand column there. So if we look at that just a little bit further, we're harping on the standard example of non-contrast CT head, but here it is in LOINC. So the LOINC code for non-contrast head CT is 30799-1. And this is just an illustration of the parameters or attributes that are used to define this orderable imaging exam. This is very analogous to the Sandbox spreadsheet that Kent was showing a few minutes ago, but in the context of orderable exams, I just want to show you this example. So this exam is defined by 4 attribute values shown in these 4 white rows. And so the first row is the modality descriptor, which is coded with a value of CT, which has a certain RadLex terminology identifier. And then the second row defines an element that relates to the use of contrast. The third row actually is the way that we say that contrast was not used in this case, so no contrast. And then the fourth row is the region imaged head. So again, just an example of how attributes and these values are used to define orderable imaging exams. And again, the purpose of going through this is that there is, I think, a close analogy here with the series and sequence descriptions that we're talking about. LOINC may provide an avenue forward in terms of one way to build codes and descriptors for series and sequences. The way that those elements for Playbook get assembled, there's a lot of information, a lot of work that went into how those elements are assembled in kind of a semantic or a meaningful way. And that model is described as part of the LOINC user guide that you can also download at loinc.org. At the very end of that document, is a subdocument called the Playbook User Guide. And again, this is an exhaustive description of that information model. Again, my purpose here is to provide context for our discussion about series and sequences. This may be a way for us to move forward in this modeling. And that's pretty much what I wanted to say about BOINC. So Audrey and Nikki, I'll turn it back to you.
Right. Wonderful. Thank you so much. It's great information. I think we're going to go ahead and move on to our Q&A. I know we have one person, George Baba Yev, I believe I pronounced that correctly. Yeah, sorry. Would like to come off mute and ask a question. So I have allowed you to come off mute.
Hi. So I also want to, mostly on IT side, but I was wondering if you have any technologies that been used to standardize those descriptions. Like I believe we attempted to do it over here at Northwell, but it quickly became very complicated where we had to introduce routers, data tables, and things like that. What have been done at your organizations, and how successful was that?
I can grab that one. Thanks, George, for your question. So I'm a big believer in, these sorts of things where you're asking people to do highly technical, detailed work where they really don't consume the work product that you're asking them to do are really destined to fail if you don't create any sort of feedback loop on their performance. So what we've been focusing on is we've asked them to make all these changes, but now we're starting to audit and look for what the performance is like. And it's always the most difficult part of this is making it real for the person who are making those changes. And then staying on top of them as, a new scanner software update comes through. And I mean, our protocols kind of barely survived those scanner updates and all the hard work that we created on those series descriptions. But I think that Kent has kind of a different approach to thinking about this. And I think both are kind of equally valid, but I just want to tee that up for him.
Yeah, so we're looking at a couple thousand facilities that there's no way that we could get all of them to agree to put in, the standardized series names. And if they did, they might start that way, but then we're going to see protocol drift and things will change. So we're building the models and algorithms to automatically standardize the names, so that when the study comes to us, we look at the DICOM headers and we look at the pixel data to determine what the relevant fields are, and then build our standardized series name off of that.
But I just wanted to make the point that, regardless of the approach that you take, having the ability to have a lexicon and a framework in order to define those standardized names, it really works for both approaches and makes the data much more interchangeable.
Changes you're planning to make are on the receiving end versus on the source?
Or by some intermediary, I think is what what Kent described. And I know that there are some commercial vendors that are working on platform or on products to do that as well.
And do you know of any work being done in the AI space where AI tools would be used to analyze that data and then just say, hey, this looks like a Excel or Sagittal or something of that sort?
Yeah, we've built algorithms that use a combination of just simple DICOM header extraction and pixel data. So we're doing AI machine vision on the pixel data to establish the body part and things like that, contrast, things that you can't reliably get out of the DICOM header.
All right, thank you.
I think it's a good, or we're basically answering, I think, the question that I saw in the Q&A from Aman Goyal, which is basically saying which is preferable to create the series descriptions in the scanners, which I think is what Mark and UCSF have done largely, or sort of the alternative is what Kent has done. And I think maybe it's obvious, but we're not trying, RadLex is not trying to prescribe which way you do that. I think both are equally valid, and it depends a little bit on the control you have over your scanners versus the complexity that someone like Kent might see. So either way, whether it's an intermediary or your PACS, to tag more of those as they come in, I think is perfectly fine. And Mark makes a good point about the feedback to the folks that are doing that work.
Okay, great. We have a couple other questions in our window. Don Dennison asks, for an enterprise starting to normalize, which modalities/sections would you recommend starting with, considering likelihood of success and impact of value? Also, what role do technologists play in the process?
I would recommend starting with CT. And we actually had this same conversation when we started this process. We initially considered doing CT and MR, and then kind of dialed back a little bit and said, well, let's start with CT. Two big reasons. CT is very common, so big impact if you can improve it. And CT is just complex enough that it does take something like this to satisfy your hanging protocol and AI use cases.
I would agree. We did have this discussion. I think we kind of peaked at MRI, and we said, like, we first have to figure out how we solve CT before we take that on. In terms of impact, I would say for operational impacts, CT is great, and it will help with display protocols, which at Stanford, when we were asking wellness questions of our radiologists, if you could solve display protocols, you will take away the number one source of dissatisfaction with workflows that we have within our organization. But for analytics purposes, if you could standardize MRI, we are in the middle of a very large project to reduce our MR scan times. And what we did discover is this lack of standardization across machines means that we have these large data sets where very similar pulse sequences on different machines are named differently. And it made it very difficult for us to figure out like average times, because we didn't even have a naming convention. So MRI, because it is a time-intensive modality, would be fantastic to standardize so that you could do operational improvement, but it is hard to do that.
Wonderful. Okay. I am good. Les Folio has a question and his hand is raised. I'm going to go ahead and allow you to talk.
You sure you want that, Nikki?
I don't know, but we'll go for it.
Mark's laughing like, don't let him go. Yeah, I posted, I don't know if it made it to everyone. And by the way, this is the most informative and important webinar to me. The only thing wrong with it is it's about 10 years too late. When I was at NIH and trying to manage the zoo of CT with 4 vendors, it's just a nightmare. And conversations with Ken and Mark were psychologically relieving. This is more so to see that this is a widespread problem. But are we okay for now just going with our the RadLex playbook, short description for starters, modality, body part, and then the more complex things after that? I mean, that's been kind of my philosophy, to just kind of get the head CT without contrast and the chest CT without contrast, the other kind of simple, not so simple analog.
Yeah, I mean,
that's
maybe
I'll
take a stab at answering that. And thanks for being here, Les. Well, I would say that I think part of what you're getting at is the subtlety of what we're describing today, which is that at some level, the orderable exams are one thing, non-contrast CT head. Playbook has already attempted to address that set of things, versus series and sequences, a different set of things that Playbook doesn't really attempt to address in terms of, well, slice thickness and sequence weighting and lots of other things. But the subtlety is that there's certainly overlap. And so you saw us talk about body part as part of a series descriptor. And so there are some of these elements where there will be some overlap in the meaning between the exam descriptor and the series descriptor. That being said, if your question is about, well, how to think about things at the exam level, then Playbook is a way, and it's a way to do that a fair amount of thought has gone into. But again, it's missing and never intended to address a lot of the series specific attributes. That is really kind of the focus of what we're presenting today. I'm not sure if that answered your question, but those are some thoughts.
It does, and I feel like keeping it simple and going by the modality, body part, short description, long. Even though RadLex isn't the Bible, it certainly is the best reference. And I appreciate all your efforts and great job, everyone. I feel like I needed something like this, like a AA meeting for, hi, I'm Les, and I have issues with my series descriptions. Thanks again. Great webinar.
Thank you, Les. All right, we have a question from Dr. Hirschhorn. Do you preserve the original series description in the DICOM header? And if so, where?
We do. We just put it in a private field, an odd numbered field. But I'm not sure if that's the best way to handle it, but that's what we're doing.
Yeah, I think we, because we're not currently rewriting it, because we're doing it in the scanner, we don't have that original field in our current implementation. But I think that, there are many reasons why it would be good to stick that into a private tag.
All right, great. Another question from Aman Goyal. Have the vendors been receptive to such standardization in the scanners? Wonder if series names on the scanner can be generated dynamically based on parameter values entered. And that might be a question for our vendors. And I don't know, we don't really have any on at the moment.
Well, Mark could probably speak, I would guess, best at this in terms of real world experience, and I can offer some philosophical take if he wants. But Mark, have you had trouble doing that with your vendors?
So like I said earlier, I think that one of the challenges is that the vendors often hard code things. So some of our MR sequences say like water in caps colon and fat in caps colon at the beginning. So we at UCSF have not yet tried to approach the vendor community. I think that once we have this kind of body of work that is approved by an organization like Loink and also RSNA behind that, I think that lends a lot of credibility to going to the scanner manufacturers and saying, here is this thing that exists and is approved, please start building that into your products. I think it's important to understand how long that diffusion process actually takes to get into practice. I think even if we got them to commit to doing this today across the board, that we would not see that in 100% penetrance for probably 50 years. So I think we need to do a combination of both of those things in order to be successful.
Kent, the only reason I'd ask you is because your practice is taking the approach of doing it on the other side, which I think is one potential solution to handling, vendor, not being willing to participate or taking a long time. I can say one quick word about the whether you want to dynamically generate series descriptions at the scanner. I think it's a really great idea. It gets into a little bit of a complex topic that we discussed, and I don't know if I want to go into great detail here, but in theory, you could create a cookbook or drop downs like Kent has created, where someone should be able to arrive at the same series description given the base parameters that go into that, no matter where they start from, independently, et cetera. We have found, or at least we believe, that this is a complex problem enough that it'll be very hard to ensure that uniqueness. And the history of the playbook with RSNA ran into some funny problems when they allowed anyone just to independently generate study descriptions. So we are taking the approach for the moment of creating and identifying each series description as it goes. Now, that's a very complex and difficult task with a lot of potential series descriptions out there, but we would like to have a certain ID with assigned to each series description with some governance around that to make sure there's uniqueness and appropriateness, et cetera. And that also segues to David Clooney's next question, I think, which is perfection is the enemy of good. So is there value of just deploying, a smaller set of series first and then incrementally expanding and moving on to some of the quote unquote more freaky ones that live out there? And that is our approach. We're going to try and start, with a relatively small cohort, and then we would like to have a website where people can come and discover the series identifiers that we've already created and submit requests for new ones, or use something akin to what Kent created for our spreadsheet, where they can put in drop downs, see what that creates. If it's not an already identified series description, we will collect data on that, so we know that people are looking for that kind of stuff. And our goal is to have some, iterative governance around that to continue to expand the series playbook. So.
And I just want to touch, there's been a few questions asking if technologists were involved or PACS administrators. And I just want to address that. It sounds like, I think, Mark, that was a part of the input at the original onset at UCSF. So this is trying to be inclusive and make sure that we're making the process easier for everybody in the workflow.
Yeah, the way that I read that comment was specifically about the webinar. And not about the actual development of the series descriptions, but you're accurate in that, and it's a multidisciplinary approach to success here for sure.
Wonderful, thank you. Another question from Teja Mathai. While there are many exam protocols that require standardization, which are the main or major ones that require immediate standardization, CT and MRI specifically?
I think when we approached filling out the amazing sandbox that Kent constructed, is that we all looked at the most common exams performed at our institution, and so just queried like I did the 20 top most common, and just pulled the data for those this is where we're going to start across our institutions to make sure we're addressing the most common exams for people across both private and academic settings.
And we found that if you hit the top 20, that's roughly 80% by volume. So that's pretty big impact.
All right, thank you. Another question. Oh, go ahead.
No, you go ahead.
Okay, another question from Dan Jiang. Assuming we want to undertake this standardization for CT, how long do you think it would take to reprogram all the series descriptions on one scanner? And who do you recommend does the series label reprogramming?
Well, at UCSF, it depends on the scanner, and the work was really done by our technologist leads, and it took about somewhere between 45 minutes and an hour for them to do so. I think that going forward, in order to make this sustainable, we would want to bake that into our just regular protocol maintenance upgrades and protocol changes, such that whenever somebody touches one of those protocols, that they ensure that it matches our standard. So I think that we did a big push as a part of our PACS implementation. I don't think that that's sustainable for every organization, as Kent has mentioned. But I think that once you have that standard, asking people to ensure that it's followed as you go forward is going to be really helpful.
Thank you. Another question from Marcus Bigby. Is there much involvement, participation in this critical effort from private practice?
Well, I'm in private practice, so.
Yeah, we were very excited that Kent and Radiology Partners was excited about this, because we really do want to be inclusive and of both academic and private groups. So that is absolutely a goal.
Oh, and towards that end, Kent, you mentioned it very briefly, but do you want to say a little bit more about the scale of Rad Partners?
I'm sorry, about you say that again?
Scale.
The question again?
The scale of your practice.
The rest of us.
Right. So Radiology Partners, we have about 3,300 radiologists. We read about 45 million exams a year and have 3,000 or 4,000 different facilities that we read for. So a lot of heterogeneity in that. And so being able to rein that in and standardize both the study names and the series names is a big deal.
Yeah, so at this point, we need to make sure we actually have academic representation. is the
So we do have a couple of nice comments in the webinar chat. So thank you to everybody who is engaging here. Do we have any additional questions from the audience? Feel free to raise your hand or drop them quickly in the Q&A box. And while
Nikki, I just wanted to surface two of the things I think that David Clooney mentioned that looked like they got marked as answered live, but I don't think we necessarily addressed. One was the perfection of the enemy as the enemy of good. We have definitely applied the 80-20 rule here in multiple places. I know at UCSF, we just said anything created by our 3D lab is not something that we're going to work on standardizing because it's just not in scope. And then David also mentioned, which I think is helpful, that there's a specific DICOM attribute sequence called original attribute sequence that can be used to store things that you have changed after the fact.
Thank you.
And we can quickly address David Broussard's last comment too about, it was more of a comment, but saying that it's difficult to have vendors do the tag mapping or tag morphing. I think most people are aware of this, but there are certainly, a number of good third-party vendors that you could do this independently. So you have to arrange your routing and so forth, but you don't necessarily have to have your vendors do that.
Great, thank you. All right, and Maria Lopez, yes, this webinar is being recorded and will be on the SIIM website. It is actually going to be one that will be open to the public because it is such an important issue that is trying to be worked through. So yes. Okay. So do we have any final thoughts from our webinar speakers and panelists today?
Really appreciate the engagement and feedback. This is really exciting. This was a bit of a slog for us at times, and just knowing that this is important to a lot of people is really energizing.
Yeah, I love the new Zoom reaction thing where they just kind of bubble up in the corner. I really appreciate all of your reactions. Thank you.
Yeah, I would just say, if anyone's interested in the initiative, please reach out. I'm happy to serve as a point person for that. And again, just thanks so much to the group that's on this webinar for all the hard work they've done so far and all the hard work I expect from them in the future.
All right. Well, thank you once again, everybody. This was absolutely amazing. I also wanted to share, this is obviously not just an issue that is that's being seen in radiology, but across imaging as a whole. And the HIMSS-SIIM enterprise imaging community has been doing a lot of work on this as well. I've dropped a few resources in there for anybody who would like to read them. And wanted to go ahead and just close out our webinar here. We have a bunch of upcoming activities. Just want to bring your attention to a couple of great enterprise imaging webinars. We have a tech tools webinar coming up as well, and the HIMSS-SIIM HIMSS and SIIM conferences. So we hope to see everybody there. And as a reminder, SIIM and HIMSS members are eligible for IIP-CE. SIIM members, this will automatically be recorded in your SIIM-U account. If you're a HIMSS member and do want to get this, just go ahead and send us an email and we'll make sure that they get published for you all. And one last thing is just help us plan. We're constantly doing activities like this, webinars, meetups, and we just want to have your feedback to help us know what you need in your work and your practice. So once again, thank you so much on behalf of the HIMSS-SIIM Enterprise Imaging community, and have a great day.